Okay, the graph shows how the speed of a cyclist varies during a time section of length 120 meters along a straight track. Okay, so they put speed there, right? Velocity, though, right? What we normally see. Okay, so it's considered the same action, though. Okay, so we've got then the different time intervals. In part A, then it says find the acceleration of the cyclist during the first 10 seconds. So you can see here during the first 10 seconds. Cyclist is indeed accelerating, right? We've got a positive gradient here, yeah? It's going that way, positive. So we'll work out the acceleration, okay, here, simply by using the gradient function, right? Working out the gradient of the line there. That will give me the acceleration. But remember, acceleration, the gradient is change then in velocity divided by the change in time. Okay, so if we look at forming a triangle here, okay, we can see it here without even drawing it. Okay, the change in time would be 10 seconds, yeah, and the change in velocity was going from 3 to 8. Okay, so ignore that 5 there because that 5 is relating to the speed that it settles at. Okay, so just look at that long line there. So change in time is 10 seconds, change in speed is 5. So literally 5 there, divide by 10, which is 0.5 meters per second squared. Okay, and just like before in the first question, you can use Suvat as well, and it'll come out to check. So part B then, it says after the first 15 seconds, the cyclist travels at a constant speed of 5 meters per second. So there you go, right? There he is there. Or she is, 5 meters per second, for a further t seconds. To complete the 120 meter section, calculate the value of t. Okay, so the cyclist keeps going at this speed for further, for further t seconds. So on my scale here, that's where the cyclist comes to a stop. This would be, if you like to think about it, well, it'll be an extra t seconds added on to the 15. So this would be like 15 add t, if that makes sense, yeah? Because it's an extra t seconds added on to the 15 there. Okay, so because we know that, okay, and because we also know that it's a 120 meter section, we know, of course, now that the total distance is 120, but we also know the total distance on the velocity time graph is quite simply the area, okay, under the graph. So the area under the graph has got to equal to 120. Okay, so all you've got to do is work out the area underneath here. Okay, if you prefer, we can sort of close that off there, so it kind of you can see then 3 sections, if you like. I would consider it as 3 sections. Ignore this sort of broken line going across there, because that might put you off. Just ignore that. So we've got section A here, section B here, section C. Now, section C is the easiest, isn't it? Because it's a rectangle. A and B are trapeziums, okay? If you turn them on the side, you'll see even clearer how it is a trapezium. So you've got that parallel with that, okay, so that side, and then the height between them, and then you've got trapezium here, this side is parallel with that side. So for the areas, let's just do all this in one go, okay. So we've got half, using the trapezium formula, remember now it's half, the 2 parallel sides added together, so 3 here, added together to 8, okay, so 3 added together with 8, times the distance between them, which is 10, plus then the area of the second trapezium, so that length there is 8, and then the parallel side length is 5, times the height between them. Now the height between this one is different, it's going to be 5, isn't it? Plus then this area. Now this area, rectangle, so it's just length times width. Now we know the length here is 5, but we know the width is t, isn't it? That was the extra t seconds. So that'll be 5 times t, and that equals to 120. So all you've got to do then is use a calculator. We'll work each of these out. Okay. So that becomes 55 there. Okay. that becomes 32.5 here. That becomes 5t equals 120. So then we can put these together here. So that would be 87.5 plus 5t equals 120. Take the 87.5 over. Okay. And we get 32.5. And then t will be 32.5 divided by 5. And we get our answer out to be 6.5. Okay. And that's exactly what they wanted, didn't they? They said calculate the value of t, so that's how further he goes at that constant speed.